Welcome to the last systems training video for math tutors. We're going to talk about word problems that involve systems today. And the main thing to remember is that you need to make two equations, one for each of the two groups. We'll talk about what those groups mean. Here's an example. All right, our drama club sold 311 tickets for a play. Student tickets cost 50 cents each. Non-students cost $1.50 each. If all of the sales, there we go, total $385.50, find how many tickets of each type were sold. So our two groups is there's going to be one equation for all of the money, because those are the two totals that we have. We have a total for money, but we also have a total for tickets. This is what I mean by two equations and one for each group. So one for the money, so 50 cents, 0.5, I want to write that. For student tickets, so let's call the student tickets X. And the non-student tickets we'll call Y. Those cost $1.50 per ticket. So we'll multiply those. And then add these two terms together, and that will give us our money total, $385.50. Then tickets, we know that there is some number of student tickets and some number of non-student tickets, equaling out to our total tickets, and there's our two equations. Now, we can solve this with substitution or elimination, but the main thing for this video is just figuring out the equations. So we're going to go ahead and skip that. If you want to solve it on your own, the answer would be 230 non-student tickets and 81, what is it, interesting, 8 student tickets. Okay, let's look at ones that involve percentages and mixtures. So on these, again, you want to make sure that you are setting up two equations, one for each topic or group, however you want to think about it, one for each total. Okay, on this first one, a total of 6,000, we're talking about money again, is split between two accounts with annual interest yields. Okay, two accounts, X and Y. One of them, let's say X was at 4% and Y was at 7%. If there was a total interest of $384, how much was invested in each? So we're going to have, again, two groups, one for the total money invested and one for the total interest. Total money, we'd have just 6,000, right? So X plus Y, our two accounts, together equals 6,000. And then our total interest is going to be 4% times the X account and 7% times the Y account equals our total interest. Okay, there's actually a formula to help you with problems like this. Ones that specifically involve percentages, this one and the next one. Okay, if we have P is one percentage, P sub 1 and P sub 2 are two different percentages, and V is for volume, volume 1 and volume 2. And then our final would be a certain percentage times the total volume. And this one, they already gave us that multiplied out as 384. And so we don't need to replace it with that, P and V. But this is the idea that we have certain volumes, you have even done this in the last one, of money in this case, in the first problem here. And then we have a percentage times each volume, or a dollar amount times each volume, like the last slide. And that gives us a different total. So for looking at the second question, we have a 10 liter, right? So we have a volume and a percent. And we mix it with a 3 liter volume, 80% alcohol solution. What is the percentage alcohol concentration of the final mixture? Okay, let's set this up. So we're going to have first our percentage volume equation. So we're going to have 0.2. The nice thing about this problem is it actually gives you some of the values of the variables times 10, right? There's our volume times percentage, and mix it with a 3 liter of 80%, I'll call solution. And then I know what the percentage alcohol concentration is. Now, this one we don't know the percentage, that's what we're trying to find, P sub T. And we don't yet know the volume. Two variables, interesting. All right, and then here we have volume 1. We already know that is 10. And the volume 2 we already know is 3. And total volume would be V sub T, aka 11. Which we can then solve this one using that 11. We'll plug that in here for volume, total volume, and we can solve. So this one is interesting. We didn't need to use systems like substitution or elimination with any of those system processes, but we just need to use, I guess it is substitution, but we have an actual value of the variable to substitute. And we're just finding one variable instead of 2. So let's go ahead and finish solving this one. 20% times 10 is 2, 80% times 3 is 2.4, and we're at 11 percentage sub T. Don't know what that is. Add these 4.4 and divide by 11, and P sub T is 0.4 or 40%. So you added a 20% of 10 liters and 80% of 3 liters, and then we get 40% of our 11 liters is alcohol. There you go. So this setup, and this is still the same idea of having two separate equations, one that is the total volume and one that is the percentage times the total. Still have this idea of having two equations, one for each topic. Okay, let's compare some speeds. We're talking about the wind and an airplane. Okay, an airplane is flying. That looks like a fish. I'm trying to draw airplane. Airplane is flying with the wind. It still looks like a fish. I don't know. It's flying with the wind. The wind pushes it, it helps it along. If it is flying against the wind pushes it and it slows it down. It subtracts from the speed of the airplane. That's important to remember. And I'm going to draw a little table like we've done before with distance, rate, and time. So let's have our against the wind and with the wind. Okay, we're still doing distance, rate, and time. Right? Time, distance. We'll fill these in. It's going to feel a lot like the other problems we've done. Just going to have two variables. All right, against the wind, a commercial airplane in South America flew 630 miles. So we do know the distance is 630 miles in 3.5 hours. So there's my time, 3.5. With the wind, so with the wind helping it, the same trip took just 3 hours, so it's faster, which makes sense, because the wind was helping it. What was the speed of the wind? Same trip, so same distance. We need to find both the speed of the wind and the speed of the airplane in still air with no wind. All right, we have something missing here in our table. The rate is missing. So we need to figure out, okay, distance equals rate times time. And so we'll fill that in a minute. That'll be our equations. But let's just say the speed of the airplane, let's call that P. And the speed of the wind, we're going to call W. So plane by itself is just P. And the wind by itself is just W. Against the wind, it's slowing it down. So our rate is going to be the rate of the airplane minus the rate of the wind, because the wind is slowing it down. With the wind is going to be helping it. So we're going to have the speed of the airplane with the speed of the wind added on. All right, distance equals rate times time. Our rate, I'm going to write T times rate so we can distribute easier. So it will be, for against the wind, 3.5 hours times P minus W and then with the wind, it will be 3 times P plus W. If we distribute that, we can even solve and substitute, but we can use elimination. P minus 3.5 W. This one would be 3P minus 3W. Okay, one word of caution. We can see, 630. They're equal to each other, so we can just set them equal to each other. But that still has two variables, so it doesn't solve the equation for us, but it would give us a third equation. So let's just say we're going to do, we could try it. Let's see what happens. So we're going to set them equal to each other. 0.5W, 3P plus 3W. Set those equal to each other, we get, subtract 3P, 0.5P equals 6.5 if we add the 3.5 over. And then divide by 0.5, we get P equals 13W. We could subtract it, or not subtract, substitute that. So let's pick one to substitute it in. Let's go right there. 630 equals 3 times 13W plus 3W equals 630. Oops, I already did that on the other side. And then distribute that, so we get 3 times 13 is 39. Add those together, and we get 42W divided by 42. The wind speed is 15 miles per hour. Now we just need to find the plane speed. 13 times 15 is 195. Now, there's a few different ways we could have solved this. I just use substitution. That works. Okay, big thing again with equations. Systems of equations and word problems. Make sure you're having 2 equations, one for each group. And there you go. That is all of the systems of equations videos. Go ahead and try out that worksheet.